Hypertext Transfer Protocol, or HTTP, is an application layer protocol for displaying HTML web pages. Each web page will often include several referenced objects, such as another HTML file, an image file, audio file, or something else. In order to exchange these objects with a remote server, HTTP uses the Transmission Control Protocol, or TCP, to reliably transfer the data between the client and server. To set up the connection, there is an initial handshake TCP connection that establishes the socket connection on port 80 of the server machine and a unique port on the client machine. The total time to send the initial connection request and receive a confirmation response from the server is roughly equal to 2 times the propagation delay of the physical circuit. This is otherwise known as the round-trip time, or RTT. After this initial handshake, the client can exchange an object payload with the server. This delivery of an object is equal to a second round-trip time, as well as the delay in pushing all of the object's packets into the network wire. In a non-persistent HTTP connection, the TCP connection closes after each object request. This means that each request from a client will require a brand new TCP connection, including the initial handshake. This entire process is equal to 2 RTTs, one for the handshake and one for the payload, plus the transmission time to load the packets onto the network. However, a web page will typically have several referenced objects it needs to fetch, and establishing new connections for each one can be costly in terms of time. There is also additional overhead for the operating system to process and set up these TCP connections. This can be offset in part since browsers will open parallel TCP connections to fetch objects. However, it's still not a desirable situation. To address these setbacks, there is persistent HTTP. In this case, the TCP connection stays open, or persists, and multiple objects can be sent over a single connection. There is only one handshake request at the beginning, followed by any number of object requests thereafter. If there are many objects to fetch, the time can be greatly reduced by cutting out all those additional round-trip times for the initial handshake. At a basic level, this means that the total time is instead equal to 1 round-trip time for the handshake, and 1 round-trip time for each object, plus the transmission time. In fact, through a process known as pipelining, whereby the objects are requested at the same time, it is conceivable that all the objects could be fetched in a single round-trip time plus the transmission time. Here's an example problem that compares the two types of HTTP. A client's browser sends an HTTP request to a website. The website responds with a handshake and sets up a TCP connection. The connection setup takes 8.4 milliseconds, including the round-trip time. The browser then sends the request for the website's index file. The index file references 22 additional images, which are to be requested and downloaded by the client's browser. Assuming all other conditions are equal, how much longer would non-persistent HTTP take than persistent HTTP? One way to do this is to look at the number of round trips in each scenario and then calculate the time difference between the two scenarios. The first step is to count the number of objects that we're requesting. This will equal n. There are 22 images, and there's also the initial index file that references those images. In total, there are 23 objects that we need to fetch. The second step is to calculate the non-persistent round trips. Here there are 2 round trips for each object, since one is needed to establish the initial TCP connection, and another is needed to get the file. So the total round trips is equal to n times 2, which is 46 in this case. The third step is to calculate the persistent round trips. There's 1 round trip per object plus the initial TCP handshake connection. So the total round trips for persistent HTTP is n plus 1. In this case, it's 24. Finally, we take the difference of the 2 round trips in each scenario, and then we multiply it by the connection time. So 46 minus 24 is 22, and then we multiply it by 8.4 milliseconds, and the result is 184.8 milliseconds, which is the answer. So the time saved using persistent HTTP versus non-persistent HTTP would be 184.8 milliseconds in this case.